Today we're going to talk about the triangle midsegment theorem, section 5.4. Now let's think about these words here. First off, the word midsegment. What are some of the words in the word midsegment? What are some that you identify? Mid and? Segment. So what's a segment? It's a line. And what's mid stand for probably? Middle. So what we're talking about today is in a triangle, if I have the midpoints and I connect them, that is what's called my mid-segment. So it's in the middle of the triangle, and it's a segment that connects it. All right, so triangle mid-segment theorem, section 5.4. The mid-segment of a triangle, like we just talked about. The mid-segment of a triangle is a segment that joins the midpoints of two sides of the triangle. So again, if I look at it here, say I have a triangle. I have the midpoints here, and that's my mid-segment. Okay? Now, let's think about it here. If this is my midpoint here, what do you know about the lines on either side of it?
The same.
Wouldn't these two both be the same?
Yeah.
Well, if this is a mid-segment, what do you know about the lines on either side of that?
Same.
They'd be the same as well. Okay? So that is two unique parts. Is there anything else you might be able to tell from this diagram that might be true? Well, we know the parts are congruent there, right? There are two other unique properties about the mid-segment. Okay, the next one's going to show us one of those unique properties. All right, so here's again what we just talked about. Mid-segment, be congruent there. And those would be congruent as well. So here's what we're going to find. Let's look at this mid-segment, or this triangle, and see if there's anything else besides there cuts up the midpoints there that we can find. So use the figure for exercises 1 through 4. AB is a midsegment of RST. It says for us to find the slope of midsegment AB. So here's AB. What's another way to think of slope? It's always as rise over run. So slope of AB. Who thinks they can give me the slope of AB there?
2, 1, no.
2.
Down 2 over 2, right?
That'd be negative 2.
So negative 2 over 2 or
Negative.
-1. Awesome. So the slope there is -1. Then once we find the slope of ST, well, here's ST. So I want to find the slope of ST now. Rise over run. What's my slope of ST going to be?
-4 over 4.
-4 over 4, which equals -1. What do you notice about the slopes?
Same.
Slopes are the same. So what does that make my two lines there?
Congruent.
Parallel.
Or
Parallel. So not only are they at the midpoints, but it also forms two parallel lines. That's great. So number 2, what can you conclude? They're going to be parallel. Now number 3 says find AB and ST. Now it wants me to find the length. So here's AB. It wants me to find the length of AB. I can use the distance formula. And it says distance formula. What else could I use? What's just like the distance formula? Starts with a P. Pythagorean theorem. Could I use Pythagorean theorem here to find the distance? You bet. So I have a right triangle. 2 and 2. So what's 2 squared plus 2 squared? 8. So AB is the square root of 8. All right, let's look at the next one. Now, once we find the distance of ST. There's ST. Draw in my right triangle. I have 4 and 4. What's 4 squared plus 4 squared? Was it? Square root of 32. All right. Somebody with the calculator, do me a favor. Find what the square root of 8 is. As a decimal, what's the square root of 8? Anybody have it?
2.82.
Okay, so the square root of 8 is about 2.8. Awesome. Now do the square root of 32.
5.6.
5.6.
5. So
What's something else we can conclude now about these two lines? What's the relationship between AB and ST, O'Connor? Yeah. Either way you look at it, the mid-segment is going to be half of the actual length of the triangle. So the midsegment is 1/2. And those are two unique properties we're going to be using today to help us out. So not only does it go to the midpoints there and cut the triangles in halves, but it also gives me some parallel lines, and it shows me that it's half of the other line. Now, why would that make sense? Let's think about it. If this is the midpoint, right? What's the midpoint go to? The middle. So the middle is usually halfway through, right? So if you connect the halves, well, you're going to get a half segment. So again, we just talked about it here. These two segments here are going to be parallel. And it's also going to be half. So if ln is 10, let's say, what's PQ going to be? 5. PQ would be 5. Or we can look down here at the example. It says AC down there is 12. If AC is 12, what's HJ going to be?
6.
Okay, very good. Or we can flip it around the other side. It tells me that JK here is 4. If JK is 4, what's BA going to be? 8, because I can then double it.
Is that all we do? Like, do we have to
So let's try these 4. All right, and again, if you think about it, it's not so much the math that's difficult, it's recognizing some terms and some points. So 8 says VX. I want to find VX here. There's VX. Who has an idea what VX might be? Ty, what do you think, bud? He says 23. Why is it 23? I agree. Yep, GH here is 46. So 46 divided by 2, that's going to be 23. Nice job. Next one. It says HJ. I want to find HJ. Reed, what do you think it is? Reed says 54. Why is it 54, Reed?
Well, because 27 is half of the HDA, so you double.
So 27 times 2 gives me 54. There you go. All right, now comes the tough one. It's always a good one here. Talk about some angles. Once we find angle VXJ, so on this angle right here, any ideas as to how I can find that angle right there? Close. You're thinking it's 92, and I agree with that. It is 92. Does anybody know why it's 92, though? Chris, why?
Because xj is same as hx.
See this angle right here? That one's 92 degrees. Well, let's look at it. Didn't we talk about these two lines? What are they? If they're parallel, what type of angles are the red ones? Corresponding angles. In parallel lines, are corresponding angles congruent? You bet. Look at that. Using some prior information we've learned. And the last one, it wants me to find xj. So it wants me to find xj right here. Well, if you recall, what was hj? 54?
54,
So what's xj going to be?
54.
Divide that by 2.
Yeah.
What's 54 divided by 2? What was it? 27. Well, isn't that just the same as WV?
Yeah.
You bet. Again, as look at this. Think about it. Is any of that math really difficult? We're dividing by 2. We're multiplying by 2. We got a same angle and dividing by 2. What's the difficult part in this? You have to be able to recognize, well, what's a midpoint mean? What's a midsegment mean? What do corresponding angles represent? All those different parts that we've already learned, and we're tying them in together in this. That's what you need to recognize. All right? Take a couple seconds to try these 4 on your own. Okay, so let's look at number 12 here. I want to find ST. Well, if DC is 36, what's ST going to be? Read.
72.
How'd you find that?
Oh, I don't know. I just doubled it.
36 times 2. Nice job. 13, I need to find DE. Spencer, what's DE going to be? How'd you find that, Spence? 44 divided by 2? Great. Now 14, angle DES. Quinn, what are you thinking about angle DES? 48? It is 48 degrees. Why? Alternate interior angles. Nice job. Yeah, if you look here, there's ST and DC. Remember, they're parallel. So if this is 48, this one has to be 48 as well. Alternate interior angles. Nice job. And the very last one now, I need to find angle RCD. So here's angle RCD. What's the angle measure going to be there, Beast? 48. Why is that 48 degrees as well?
Beast.
Alternate interior angles. Yep. Because there, right there is parallel lines. Alternate interior angles. Nice work. Here's your assignment.